Welcome back to my channel, everyone. So we're going to work on the integral of the 6 trigonometric functions. But of course, this actually looks the same as what we have done back then. So we're not going to repeat the same questions again. We're going to change it a little bit and make it a little bit more challenging today. So instead of just trying to take the antiderivative of all the trigonometric functions that we know of, we're going to put absolute value. In other words, we're going to take the integral or antiderivative of the absolute value of the trigonometric functions that we know, or some people just call it a modulus function. Anyway, you can pause the video and try it yourself first and see if you actually can get it the same answer with me. Are you ready for it? Here we go. So if you have actually watched another video of mine, we actually have talked about how to take the integral or antiderivative of a modulus function or a function with absolute value in general. In other words, we actually have seen the results of the antiderivative of absolute value of a function f of x with respect to x. And in that video, we say that the antiderivative of it will actually be the same as the antiderivative of the function itself, of course, with respect to x, times the sine of the function itself. In other words, we can technically rewrite the sine of the function as the function over the absolute value of the function. Again, you can switch the order and it's not going to change the general result of it, as we're just trying to take the antiderivative and we assume that the function that we're taking will be continuous, and we will be able to assume that it is nicely defined what the sine would be. But anyway, with this, we'll be able to guess the answers for these problems quickly. So what's the first one? Well, we have the absolute value of sine of x. So by the general expression of the antiderivative of absolute value of a function, we will be able to get the antiderivative of the function itself, which is sine of x, which is negative cosine of x, times the sine, or actually, in fact, we'll keep it as the absolute value of the function over the function itself. Okay? In other words, we can now combine it as absolute value of sine of x times the negative, which we actually bring in the front. And then times, what is cosine over sine? Of course, cotangent. And this is how we can actually get our answer quickly within a minute. And of course, don't forget we have a plus c. Similarly, we will be able to get the results for rest using the same method. So for absolute value of cosine, we will get absolute value of cosine over cosine itself times the antiderivative. Again, it will just be sine. And then don't forget the plus c. And again, we can, if we want to simplify it, we can combine together so that we have absolute value of cosine, which is in the numerator, times sine over cosine, which gives us tangent of x plus c. Now, for this absolute value of tangent, of course, we first we'll get the sine of tangent function, or absolute value of tangent of x over tangent of x, times, now what is the antiderivative of tangent? Again, if you have watched my video, you already know that it will be natural log of the absolute value of cosine of x. Okay, and then don't forget we have a plus c. There we go. Now we are going to move on to cotangents. So again, we will just get the similar results, except now we switch the tangent to cotangent. And what is the antiderivative of cotangent? Again, if you have watched my video, you will be able to get ln or natural log of sine of x. And don't forget the plus c, the constant. Now back to here, be careful. Here we don't have just cosine of x, but we actually have a negative sign in the front. Again, that is because if we think, if we rewrite tangent into fractions, we have sine over cosine. And then we, of course, let the denominator cosine to be our u and take the antiderivative to get ln of absolute value of u. But if we use the u sub, what is du? Du is negative of sine. So don't forget we need to put the negative back. All right, now if we continue, we'll be able to get the similar thing. And what is the antiderivative of secant? It will be natural log of secant of x plus tangent of x. And don't forget we have a plus c. Last but not least, we get cosecant over cosecant. And don't forget we need to put one of them into an absolute value sign. And then times. Now again, for cosecant we have a negative sign here. So we get ln of cosecant plus cotangent. And then last but not least, we have a plus c. There we go. Pretty cool, huh? So if you enjoyed this video, don't forget to like and subscribe to my channel so you can find out more of my other videos. And turn on the notifications so that you won't miss any of my new videos when they come out. I'll see you guys next time.